Hi everyone, in today's lesson we will discuss another topic from design and analysis of algorithm subject, and the topic is how binary search works. So before coming to this topic, I just want to tell you guys that if you guys have not seen my last lesson where I have discussed everything about the concept of merge sort technique, then I would recommend you guys to watch this lesson as well. Okay, and if you guys have not subscribed this channel, subscribe it first. Watch this lesson completely, and if you like this lesson, then don't forget to click on the like button. So let us first have a little bit of introduction on this concept. So binary search is a technique of searching the position of an element in an array. So for searching the position, first we will have to divide the entire array into two parts. So for dividing, we have to find out the middle element. Then we have to compare the middle element with the element which we are searching. If both of these elements gets matched, that means the element which we are searching is the middle element. If the element which we are searching is not the middle element, then it will be either on the left side of the middle element or it will be on the right side of the middle element. If the element which we are searching is less than the middle element, then we have to start applying the same binary search technique on the left side of the middle element. If the element which we are searching is greater than the middle element, then we have to apply the same binary search technique on the right side of the middle element. Okay, so this is the complete concept of binary search, and we will be going to apply the same concept on this problem by considering this algorithm. Okay, and this algorithm follows the divide and conquer approach using recursion. Okay, so now let us start finding this key element 25 with this problem. Okay, so now here you can see I have taken a problem of size n, and for solving the key element 25 in this array, I have written an algorithm here. Okay, so now let us see the algorithm step by step. Okay, so here the binary search is the name of the algorithm, and it's taking the array, which is the name of the array, and low, L stands for low, which I have marked to the first index of the array, and H, which I have marked to the last index of the array, and a key element which we need to search. Okay, when we come inside the function, here you can see I am making an if condition to check if low is less than higher. So low is 1 and high is 8. Okay, so 1 is less than 8. Yes, condition is true. So what is the meaning of this condition? When I am doing this condition of low is less than H, that means there are more than one element present in this list, and the list is large, and we have to divide this entire list by considering the middle point. Okay, so now first we need to find out the middle point. So for calculating the middle location, I have used this formula. I have to pass the values of low and high in this formula. So low is 1, and that gets added with 8. Now it becomes 9, and when 9 gets divided by 2, we will get 4 as the middle location. Okay, so now we have calculated middle location. Once we find out the middle location, then we need to again come back to this algorithm to check whether the element which we are searching is equals to middle element or not. Okay, so that's what I have done here. If array of mid is 4 and array of 4 is 30, which means this is 30 equals to key, and key is 25. Okay, so now here with this if condition, we are checking whether the key element is equals to mid element or not. Okay, so now 30 is equals to 25. No, 30 is not equals to 25. That means the element which we are searching is not the middle element. So now in that case, what we need to do is we need to start applying the same binary search on the left side. Okay, now let us see here. Okay, so now I have another if condition, and in that if condition, what I am doing is if array of mid is greater than key. So mid is 4 and array of 4 is 30. Array of 4 is 30 and 30 is greater than key. Key is 25. Okay, so 30 is greater than 25. Yes, 30 is greater than 25. Condition true. So when this condition gets satisfied, we will come inside this if block to make a recursive call on the same binary search function on this array starting from low to mid minus 1. Okay, so from low to mid minus 1. So this is our low and this is our mid, and mid minus 1 means this place. Okay, so when we make a recursive call on the same binary search function from low to mid minus 1, then control will come back to this place. Okay, so in the last iteration, we had divided this entire problem into two parts. So these were our two parts. Okay, first left subproblem and right subproblem. So now in that case the middle was 30. So from that place we had divided the entire problem into two subproblems. Now when the control comes back to this if condition to check whether low is less than high, so now this will become our low and this will become our high. Okay, so we have to apply the same binary search algorithm on this left subproblem to search the key element. Okay, let's do that. Okay, so now low is 1 and high is 4, and we need to check whether 1 is less than high. Yes, 1 is less than 4. Okay, that means there are still more than one element present in this left subproblem, so we have to divide this. So for dividing we need to find out the mid location, and here we are finding out the middle location. Mid equals to 1 plus 4, which equals to 5, and 5 gets divided by 2, which equals to 2. Okay, so that means this is the mid location. Okay, so now next we need to check whether the key element is equals to the middle location or not. Okay, so that's what I am doing here. If array of mid is 2 and this equals to mid is 17. Okay, is equals to key element is 25. Okay, so now 17 is equals to 25, which is false. Okay, that means the key element is not equals to mid location. Then it has to be either on the left side of the middle element or it might be on the right side of the middle element. So now we need to check that out. So now here I have made another if condition. If array of mid is 17. Okay, because mid value is 2, so array of 2 is 17. So 17 is greater than 25. Now 17 is greater than 25. No, 17 is not greater than 25. That means this block will not get executed. Control will come in the else part to make another recursive call on the same binary search function starting from mid plus 1 to high. Okay, so because here with this condition we come to know that the element which we are searching is greater than the middle element, so it has to be on the right side of the middle element. That's why we have to come in the else part to make a recursive call on the same binary search function starting from mid plus 1 to high. Okay, so now from here to last point, from this point to this point. Okay, so when we make a recursive call on the same binary search function from mid plus 1 to high, then again control comes back to this place to check low is less than high. Okay, so now what is low? Low is 3 and high is 4. Okay, so 3 and 4. So 3 is less than 4. Yes, condition is true. Now we need to divide this because we come to know that there are still more than one element present in that right subproblem, so we have to divide that. And that's what we are doing here. Okay, so we are calculating the mid location by adding 3 plus 4, which equals to 7, and when we divide 7 by 2, we will get 3 as the mid location, and we find out that this is our mid location. Okay, now we will take that mid location to check whether the key element is equals to mid location or not. Okay, so that's what I am doing here. So I have taken 3 in this if condition. Array of 3 is 25. Okay, and key is 25. So now 25 is equals to 25. This condition gets true, and we will return the mid location. Okay, so now we have come to know that in this place, in the third index, we have the key element present, and we have identified that key element, and we found out the position of that key element with this mid. Okay, so now you have seen how I have applied the binary search algorithm on this problem. Okay, so now in this problem the key element was present in this array. What if the element which we are searching or the key element is not present in this array? Then if it were not present in this complete array, then it will be making another binary search recursive call, and it will be dividing the subproblem into further subproblem until we will be reaching to the smallest subproblem. Once it reaches to the smallest unit of the array, and if it didn't find the key element, because that element won't be present in that array, that's why the algorithm will not find the key element in that array, then in that case it will be returning -1. Return -1 means element not found. Okay, so this is the entire concept of binary search. algorithm. Okay, I'm sure you guys have understood the concept of binary search, and that's all for this lesson, and thanks for watching.